welcome to my channel. In this video, we are going to learn class 8 maths chapter 4 altitudes and medians of a triangle of SSC board. Chapter complete with deep explanation. Let's start. Remember this point in center. The point of concurrence is called the incenter of triangle. In triangle ABC, this one, ray AD, ray BE and ray CF bisector angle A, angle B and angle C respectively. Therefore, point I is the incenter of this triangle. Incenter is always in the interior of the triangle. This one. Number second, circumference center. The point of concurrence is called the circumference center of the triangle. In triangle PQR, this one, line L, line M and line this N. Line L, line M and line N are perpendicular. This perpendicular bisector of side QR, this one, PR, this and PQ here respectively. Point C is the circumference center. Number 3, altitude. The perpendicular segment drawn from a vertex of a triangle on the side opposite to it is called an altitude of the triangle. In triangle PQR, sec PS is the altitude drawn on the base QR, this one, from the vertex point this P. Every triangle has 3 altitude, one from each vertex. Number 4. In the equilateral triangle, all the altitude are of the same length. In an equilateral triangle, all the altitude are of the same. Number 5. In an isosceles triangle, the two altitudes drawn from the vertex of the equal angles are equal in length. Number next, median. The segment joining the vertex and midpoint of the opposite side is called the median of triangle. This diagram. Sec AD is the median on the base BC. Therefore, BD equal to DC. Every triangle has 3 medians. This one, B from here and C from here. So, every triangle has 3 medians, one from each vertex. Number 7. In an equilateral triangle, all the medians are of the same length. In an equilateral triangle, all the medians are of the same length. Number 8. In an isosceles triangle, the two medians, isosceles two sides equal. So, in an isosceles triangle, the two medians drawn from the vertex of the equal angles are equal in length. In an isosceles triangle, the two medians drawn from the vertex of the equal angles are equal in length. Then, this table. Type of the triangle: acute angle triangle, right angle triangle, and obtuse angle triangle. Here, position of the circumference center. Here, acute angle in the interior of the triangle. Right angle triangle on the hypotenuse of the triangle. Obtuse angle triangle in the exterior of the triangle. Position of the circumference center. Then, position of the orthocenter. Acute angle triangle in the interior of the triangle. Right angle triangle, vertex of the right angle. Obtuse angle triangle in the exterior of the triangle. Next, position of the centroid. Acute angle triangle, right angle triangle and obtuse angle triangle are in the interior of the triangle. Position of the centroid, acute angle triangle, right angle triangle and obtuse angle triangle in the interior of the triangle. Number 10. The centroid of a triangle divides each median in the ratio 2:1. The centroid of a triangle divides each median in the ratio 2:1. Practice set 4.1. Number 1. Fill in the blanks. In triangle LMN, this triangle LMN, altitude LX, sec LX is altitude. Here, sec LS, LX is an altitude. And median here LY, LY is median. Seg LY is a median. Here in triangle LMN, sec LX is an altitude and sec LY is a median. This median Y is a midpoint. So LY is a median. Number 2. Draw an acute angle, triangle PQR. Draw of all its altitude. Name the points of concurrence as O. Draw an acute angle, triangle PQR. Draw all of its altitude. Name the point of concurrence as O. Here, this one. First PA, then this CR, then this BQ, altitude PA, QB, CR, and the point of concurrence as O here. Number 3. Draw an obtuse angle, triangle STV, STU. Draw its median and show the centroid here. First, here STU, obtuse angle, STV, obtuse angle. Then from T, arc, then U, here arc both side. Then join it and center P. Then same from U, here arc, then from S, this arc both side, then join this arc. So ST, estimate point R, then same from U and from S, this, then join it. So draw its median. So here this median, this CR, then SP, CR, this SP are the medians, and this centroid, this one here centroid, this. Question 4. Draw an obtuse angle, triangle LMN. Draw its altitudes and denote the orthocenter by O. This here sec LY, perpendicular side MN, sec LY, this one, sec LY, perpendicular MN, this one. Then second, sec XM, perpendicular side LN, XM, perpendicular line, this one, LN, this. Then number 3, sec ZO, perpendicular side LM, ZO, this side LM, ZO, perpendicular line, ZO, perpendicular line LM, this one. So O is the intersection of altitudes. This altitude, this one, first altitude, then this altitude, and third one. Then O is the orthocenter which is in the external of the triangle, this. Draw a right angle triangle XYZ, this one, XYZ. Draw its median and show their point of concurrence by G. First, this right angle triangle, Y 90 degrees. Then from here, this arc from both sides, join at point P. Then same XY, XZ, arc from here, then join here point Q. Then XY, from X and Y both sides, join here R. Then here ZR, then YQ, then XP are the median. Here ZR, XP and ZR, XP and this median. So G is the concurrent points of triangle XYZ. Question 7. Fill in the blanks. Point G is the centroid of triangle ABC. Number 1. If length RG equal to 2.5, then length GC find. Second, if length BG equal to 6, then find length BQ. Number 3. If length AP equal to 6, then length AG find, and length GP. This diagram. Solution. The centroid of a triangle divides each median in the ratio 2:1. This 2 part, this 1. This 1 part to 1. So 2:1, this one. Here also 2 parts and this 1 part. So the centroid of a triangle divides each median in the ratio 2:1. Question first. Point G is the centroid of sec CR. This one sec CR, because RG given. So this CR is the median. So here length GC, two parts, length GC upon length RG GR. Length GC upon length RG equal to GC, this two part 1, so 2 upon 1. GC find, so length GC upon RG, RG given 2.5 equal to 2 upon 1, cross length GC equal to 2.5 into 2. Therefore, length GC equal to 5 units. Number 2, point J is the centroid and sec BQ is the median. This one. Here BQ, G is the centroid. So length BG upon length GQ equal to 2, this 2 part and 1, 2 upon 1. So here length BG upon length GQ equal to 2 upon 1. BG given 6, length GQ equal to 2 upon 1. So cross 2 into length GQ equal to 6 into 1. So length GQ equal to 6 upon this 2. So length GQ equal to 3 units. Then find BQ. So BQ equal to BG plus GQ. Here length BG equal to length BQ equal to length BG plus GQ. Length BG plus length GQ. BG given here 6 and GQ 3. So length BQ equal to 9 units. Number 3, if length AP equal to 6, then length AG and length GP find. Here GP 1 part and AG this one 2 parts, total 3 parts. So 1, 2, 3. So length GP, point G is centered and sec AP is the median. So length GP, length this GP equal to 1 upon 3, length 1 part GP 1 part and this 2 part, total 3 part, 1 upon 3 AP. AP given 6, 3 to the 6, length GP equal to 2 units. Then AP equal to AG plus GP. Length AP equal to length AG plus length GP. This one AG plus GP. AP given this 6, length AG plus AP here 2. So 6 minus 2 equal to length AG. Therefore length AG equal to 4 units. So GP equal to 2 units and length AG equal to 4 units. If this video helped you, please like, share, comments and subscribe for more maths video.